Hi, I'm Gavin Perez, and today I want to talk to you about the introduction to organic chemistry. This subject is notorious for being complicated because there are so many types of organic compounds with unique properties and reactivity. Organic chemistry is the study of the chemistry of carbon compounds. Carbon forms covalent compounds with itself and other elements, leading to incredible variety of structures. This discipline involves a scientific study of the structure properties, compositions, reactions, and preparation of organic compounds and materials containing carbon atoms. Organic chemistry plays a crucial role in diverse industries, including biotechnology, consumer products. Organic are found in various everyday products such as agrochemicals, coating, cosmetics, detergents, dyestuffs, food, fuel, petrochemicals, pharmaceuticals, plastics, and rubber. From the caffeine in your morning tea that kickstarts your brain to the circuitry that makes your cell phone lightweight and portable, organic chemistry is practically everywhere. There are actually 16 million known organic molecules. So yes, it can seem overwhelming, but there are patterns. Using basic tools, some practice, and by taking things step at a time. I hope you go to like it as much as I do. Molecules like 3s, 8s, 9s, 10R, 13R, 14s, 17R, 10, 13, dimethyl 17, 2R6, methyl 10, 2YL, 2, 3, 4, 6, 2, 3, 4, 2, 2, 3, 4, 7, 8, 9, 11, 12, 14, 15, 16, 17, dodecahydro, 1H, xylophenolenta, alpha phenanthren, 3, all. Otherwise known as cholesterol. And just a heads up, you will have to do some practice yourself to really master them. So yes, organic chemistry can be complicated and sometimes it can feel like you're randomly pushing around electrons and hoping for the best. But together we're going to make sense of the chaos and hopefully have some fun along the way. In this video, we're going to talk about organic chemistry. Organic chemistry focuses on organic compounds that contain carbon atoms. No carbon likes to form 4 bonds, but you also need to know the number of bonds that the other elements like to form. So elements in the first group of the periodic table like hydrogen, they like to form 1 bond. Beryllium, for example, likes to form 2 bonds. Boron, which has 3 valence electrons, it likes to form 3 bonds. Carbon has 4 valence electrons, carbon likes to form 4 bonds. Nitrogen likes to form 3 bonds. In organic chemistry, oxygen likes to form 2 and elements like fluorine and the other halogens, chlorine, bromine, iodine, they like to form 1 bond. Now, there are cases where chlorine, bromine, and iodine conform 7 bonds, but we're really not going to cover that in this video. Now, understanding that this is important because it helps us to draw Lewis structures. So for instance, let's say if we want to draw the Lewis structure of water, H2O, knowing that oxygen likes to form 2 bonds and hydrogen likes to form 1, we can start with a structure that looks like this. Now, oxygen likes to have 8 electrons. Each bond represents 2 electrons, so that's a total of 4. To get 8, we need to add 2 lone pairs, so that is the Lewis structure for water. Now the bond between hydrogen and oxygen is known as an H bond or a hydrogen bond, which is a special type of covalent bond. Hydrogen bonds occur whenever H is directly attached to nitrogen. Oxygen or fluorine, hydrogen bonding explains why water has such high boiling point. Now let's say if we have methyl fluoride, how can we draw the Lewis structure for that molecule? So we know that carbon likes to form 4 bonds, so we're going to put that in the middle. Hydrogen likes to form 1 bond, fluorine also likes to form 1 bond, so this is the best Lewis structure that we can make. And if you want, you can add 3 lone pairs to fluorine so that it has 8 electrons around it. Elements in the second row like carbon, nitrogen, oxygen, and fluorine, they like to have 8 electrons. They don't always have to have 8, but ideally speaking, they like to have 8 so that they can be stable. But that's the structure of metal fluoride. Now the carbon fluoride bond is a polar bond. Carbon has an electronegativity value of 2.5 and the electronegativity value of fluorine is 4.0. Whenever the electronegativity negativity difference between the two elements is 0.5 or more, the bond is said to be polar, so that this is a polar bond. It's not a hydrogen bond because fluorine is not directly attached to hydrogen, but it's a polar covalent bond. Now you might be wondering, what does it mean for a bond to be polar? A polarized object is an object that is neutral overall, but has charge separations. That is, one side is positive and the other side is negative. So this is a polarized object. The bond is a polar because fluorine carries a partial negative charge due to the fact that it's more electronegative than carbon, so it pulls its electrons towards itself. And being less electronegative has a partial positive charge, so due to separation we can say that the carbon-fluorine bond is polar.